two very specific theorems having to do with secants, tangents, and angles, and so we are going to look at those today. 1 second. Okay. So this one says, in circle Y, what is the measure of angle 1? So what is the measure of this angle right here? Well, what you will recall is this throws us back to the angles formed by two chords theorem, because we do in fact have two chords which are intersecting here. Remember that chords run inside of a circle from one point, or one side of the circle to the other side. So we have two chords here that intersect, and thus we can use the angles formed by two chords theorem, which is this one right here. Basically, what this says is that we can use this equation to find the missing angle measure. Okay, so we'll identify what is x, what is y. 1 second. Okay. So I'll say this one's x. Again, it's interchangeable. Either one can be x, either one can be y. But your x and y have to be the measures of those arcs on the outside of the circle. And so we're looking for the measure of angle 1. So basically, we would just put the measure of angle 1 is equal to 1/2 x, 25, plus y, 37. 25 plus 37 is 62, so 1/2. So basically, you're multiplying 1/2 by 62, which gives you 31. And so therefore, your measure of angle 1 is equal to 31 degrees, which gives us C. Okay, so basically you can identify that here you have two chords that intersect. So therefore we can use this theorem right here, which tells us to use this equation, which allows us to solve for the measure of angle 1. Okay. Is there any questions about this? Questions, concerns? Yes. Okay. So now we have this next example. And this says, in the diagram of circle C, what is the measure of angle 1? So again, we're looking for the measure of angle 1, which is this one right here. But what we'll notice here is we actually have, in this instance, we have two secants. So this theorem basically says if we have two secants that form an angle, or two tangents that form an angle, or a secant and a tangent that forms an angle, what we can basically use is this equation right here to solve for the missing angle measure. Therefore, we can solve for the measure of angle 1 by using this equation. And then x and y are interchangeable, whatever you wanted them to be. So I'll say this is x and this is y. So basically, I just plug that in. But in this case, we're using minus because we have the angles formed by tangents theorem. Angles formed by secants or tangent theorem, sorry. And so 106 minus 36 is 70. Multiplied by half gives me 35. So my missing angle measure is 35. Okay, so very similarly to the first problem, I want to identify what do I have here? What kind of angle is being formed? Well, I have two secants in this one. And remember, it can be two secants, two tangents, or a secant and a tangent. And so that tells me that I can use this theorem because I have two secants. I plug in my information, which allows me to solve for my missing angle, angle 1. Okay. Very straightforward. Any questions about this? Questions, concerns? Okay. And so lastly, we have this one, which is kind of putting a bunch of different things we've looked at so far together, but you'll see that it's very straightforward. So basically what you have here, it says in circle C, what is the measure of arc FH? So we're looking for the measure of this arc right here. Well, what you'll notice is we can find the measure of that arc if we're able to find the measure of this arc right here. I'm going to show you how we do that. So let us go back to the angles formed by secants or tangents theorem. And what we'll see is we have this angle right here being formed by two secants, as well as this angle right here being formed by two secants. So we can use this theorem. But again, what we want to locate or identify is what is the measure of this angle right here in order to find the measure of this angle right here. Okay? Well, the way we can go about answering this problem is first, because this second's angle has more information, let's go ahead and use that to find our missing angle, right? It has more information. This one has the measure of the angle and the measure of the y, and we can use that to find the measure of the x. Well, this one just has the measure of the angle. It's not giving us any information about x or y. So because of that, let's first use this second angle to find the missing arc measure. So basically we'd use this equation. The angle is equal to 1/2 x minus y. Okay, what is my angle measure? Divided by, I'm looking for x, minus y, 38. Okay. We multiply by 2 on both sides to get rid of that fraction, so it's easier for me to work with, which gives me 74 is equal to x minus 38. Okay, let me isolate my x. So plus 38, plus 38. Therefore, x is equal to 112. So now I'm able to identify that x is equal to 112. Well, now that I have that information, now I can actually go ahead and solve for my missing y, my arc FH. So I can look at this angle formed by 2 seconds right here. Okay. So again, I would just use the formula. So angle is equal to 1/2 x minus y. I know I can use this formula because I have 2 seconds that form an angle. Here, my angle is equal to 32 equals 1/2. What is x? Oh, well, I just found x. It's 112. And what am I looking for? I'm looking for my y, the measure of my arc FH. Okay. So again, the easiest thing to do is do away with my fraction. 64 is equal to 2 minus y. Okay. And then what you'll notice is y is then equal to 48 because 112 minus 48 gives you 64. So therefore, this is my answer right here. Okay. Any questions about this one? I know this one was more of a lengthy process, but any questions? I'll review a little bit. Okay. So basically, we know we have multiple angles in this case formed by 2 seconds. So we know we can use this theorem right here. Well, what you realize is what you're looking for is the measure of this arc. And so because of that, what I want to do is make this easier for myself. And instead of having 2 missing variables, x and y, make it to where I only have 1 missing variable, my y. And the good thing is that I have another angle here formed by 2 seconds. And so because of that, I can find x by using that equation, but plugging in this angle measure and this y to find the x. That allows me to find my x. And now that I have my x, now it's a lot easier for me to find my y because I don't have 2 unknown variables, I just have 1. And so therefore I can use my equation again, plugging in that x I just found. And by doing that, I find y, which is also my arc FH. Okay. So that's basically how you would go about solving this type of problem. Okay. Any questions? And it's very rare you're going to have a problem with this many steps. But just in case, now you know how to solve it. Okay. So most often you will have something that looks like this and you'll know, okay, I have 2 chords that intersect, so I must use the angle formed by chords theorem. Here I'll say, oh, look, I have 2 seconds or 2 tangents or a second and a tangent that form an angle, so I can use this theorem. And so those are the 2 theorems that we worked with yesterday. All right? Any specific questions about anything we went over today? additional information. Okay, and so just a reminder, in case you don't want to look through the PowerPoint to find all these different theorems we work with so far, the PowerPoint is here. Our lecture is here. Here are the practice problems I just went over. But if you want a shortened version of this, just go to Unit 8, go to this review. And there you'll basically just see all the different theorems outlined. Okay. 1 second, guys. So those are the 2 theorems we just looked at. Okay. Any questions? If there's no other questions, you guys may log off, and I will see you guys tomorrow. Bye, guys.